these are my students. So we are going to present about PBL review to water quality early warning for rural communities using ML model. Guided by programming.
Fatima, ಯಾರು ಮಾಡ್ತಾರೆ ನನಗೆ ಹೆಸರು ಕೂಡ ಮಾರ್ಕ್ಸ್ ಕಟ್ ಮಾಡ್ತೀನಿ ಇಲ್ಲ ಆಬ್ಸೆಂಟ್ ಆಗ್ತೀನಿ.
These are the contents included in this book.
Boys do know.
It is a problem statement. In which there is a lack of depends on well, rivers and borewell that are highly risky and it is contaminated. We don't know the water is quality is good or not. From this, use a real-time monitoring tools to detect the water quality and it tells about the result can be safe or not drinking water. And the importance is public health. By drinking the contamination water, it may diseases like cholera, typhoid and diarrhea comes. So it is a diseases. It comes to the water. And trust is rebuilds community confidence, local water through transparency. By using this model, we know by we use this model, we know the water is safe or not by using. And the key challenges is data imbalance. The data imbalance means it is danger, and contamination is rare, and latency is a data travel from one point to another point. It's the latency, and we use it for processing sensors in real-time instances. We use it latency means it gives a real-time instructions. And the
Abhilash, ಯಾರು ಮಾತಾಡ್ತಾರೆ
ways to go to develop functioning software prototype that simulates sensor data, predicts water quality and analysis. By using this, it predicts the water quality and detects that if the water has any contamination or not, and it tests the quality of water, and it visualizes through the dashboard. And specific technical course we use to develop a Python data simulator to mimic IoT sensors needs pH, turbidity, temperature. It analyzes the pH, turbidity and temperature, analyzing water quality. And implementation and training machine learning classifier we use it as a RATM for identifying and build an interactive web dashboard for real time. We build a dashboard in it shows the real time streaming. It is a recap of page 1. In summary, in recap 1 we are doing a literature survey and define system requirements on the early warning models and background research contaminated for the sensors and existing water solutions. And improvement in phase 2 is we strengthen data connectivity based on feedback about poor network. In rural areas there is a lack of poor network. So we use the added LoRa and GSM. Added LoRa is a long range and low data rate, and GSM is global security for mobile communication. So it is when compared to LoRa, it's better for Wi-Fi. Improved alert mechanism after identifying the need for a faster contamination detects. It alerts the people from identifying if the water is contamination is detected or not.
So for just collecting the data from the network, you are using GSM and LoRa models.
LoRa is a low power and high data, low data rate.
And it is giving the data from cloud itself.
Data collect.
So ಈ model preprocess ಆಗಿರುತ್ತೆ data. Preprocess ಆಗಿದೆ ಕೊಡುತ್ತೆ.
The next page.
Myself, from AI department. I am going to explain about system design. Here we use the sensor, pH, turbidity, temperature, collect water quality data. First we use the sensor. It is based on hardware and software of project. First we collect the sensors. Using the sensor, the data will be collected, and the microcontroller sends data to the cloud. Microcontroller which will help the sensor to detect the water and sends the data to the cloud. And the cloud stores and forwards the data to the ML prediction model. Whatever the model we have built, the cloud will give the data from the ML model, and the ML model predicts whether water is safe or unsafe. The major task of this our project is defining the people whether the water is safe or unsafe for the rural users, and the next after dashboard display readings and alerts the user if contamination risk is detected. Whatever we create the dashboard, it will help the people to suggest that whether it is a safe or unsafe by contamination risk detected. And this is our system design where we use the data collection inputs and the data transmission, analysis and output and action. First we use the sensor data input what we have taken and the data element model, and the IoT sensor it will collect the pH, turbidity and bacteria it will sense, and the data cleaning process. Whether the data is, if the duplicates is enabled and the missing data is cleaned and verified, the machine data is enabled as the machine algorithm. And if the data is cleaned and model, predicting analysis whether it is yes or no, it is risk or unsafe or like that. And the dashboard of whatever we have with the dashboard or the app or the system, it will suggest that whether it is a safe or unsafe. This is our system design.
So your system design is from the data set only.
Yes, but
The flow.
in future we will develop the hardware, but we are concentrated on the software.
Okay, one thing that is to clarify is that if you design an app of finding the water is contaminated or not, so how do you communicate with it?
With the microcontroller, when the data is connected to the cloud will get the pH values and the bacteria are present. That values will be given in our dashboard. That will predict, and from the training the data, it will predict whether it is safe or not.
So once I open the app, only the process will be done.
If we need to check whether it is unsafe or safe, we have to open the app and we have to check.
It is based on the location of that particular thing, right?
Based on the location and area where the.
So that particular data is not covered the location fields.
We'll make in further studies. And this is the algorithm steps. What we have done in our project, we'll start first collecting the input water parameters and pre-processing the inputs, feed the inputs into training ML models, and the ML model it is unsafe, dashboard alerts, and these are the algorithm steps what I have explained here. And next is the implementation. In the same way, implementation also same as algorithm steps data collection models. Since physical sensors are not yet integrated, simulated sample sensor data was collected. For our project, we use the sample data and the multiple reading for pH, turbidity, temperature they just in CSV format. And the data pre-processing model. Remove the pre-processing will be taken by removing missing or invalid readings, normalized values to consistency scales, extracted relevant features, split data set into training and testing set. Here we use 20% of testing and 80% of training data. And the machine learning model selected a classification based model. Training based.
Which classification model is it? Which classification?
Random forest.
Random forest. You have to mention.
Trained baseline model using pre-processing data. Implemented prediction function to classify whether water is safe or unsafe. And calculate accuracy and final tune parameters. Backend or app preparation, designing app structure like predict endpoint, accept input, returns predict water quality status like we have for backend, and connected ML model output to backend logic. And the dashboard UI, whatever is the dashboard, create initial dashboard layout, added placeholder for pH values, stability graph, temperature trend, and prediction output will be displayed in the dashboard. If we put the values, it will show whether it is if the green is safe, yellow, and moderate, red, unsafe. These are the designs what we have used. And the technologies will be explained by my friend.
Hello everyone, myself Chinmay from Environment Department. Here is the technologies which we use, front-end technologies like framework. Framework is used for build a website for user, and React.js with or JavaScript, and HTML5 for structure, and CSS3 for style and UI. And
Which framework you used?
the framework Flask.
Flask. It is a tool.
Framework. for front. Languages like
Avoid the bad idea control.
CSS or Tailwind, and we can use Tailwind CSS for modern responsive UI style. Here is the backend technologies framework, AppUI framework, Flask and Python and Flask web framework and Flask course. It is for choice our front end to access backend. For connection, we can use Flask front end to backend. And backend libraries like Pandas, data preprocessing, and NumPy for numerical operations, and Scriptum for model operation, model learning models for random forest. JobScript for model saving and loading the data, and JSON for logs file storage. And here is the challenges and solutions. In challenge 1, the lazy model problem. Is if the water is safe 99% of the time, it shows unsafe. We use lazy model, and it's if the predicted is if the water is safe, it will show unsafe. And to check the and our try to check the predicting safe for to get the high score. To get the high score, it check the model. If it shows safe 99%, it shows like it is unsafe, and it is a solution. We balanced the data. We forced the model to study dangerous scenarios, more study as it does not miss the or contamination units, and the challenge to avoiding false alarms, and it gives the false notification through SMS. Here the problems, sometimes sensor glitch for just 1 second. We did not want to send a panic SMS to the whole village for a glitch, and here is the solution. We added time rule. The system only sends an alert if the water changes for continuous readings, confirming it is a real problem. Here is the future of the next case plan. First, advanced for testing model. Goal is to predict contamination before it happens, proactive versus reactive. Here is the goal to predict the contamination level, it is safe or unsafe. We have planned to upgrade machine learning model random forest to LSTM, long short-term memory networks. These deep learning models are used for time series forecasting and can predict trends 24 in advance. It can predict 24 in advance. In second, model application for field agents. Goal is to enable on ground techniques to receive alerts. It give ground alerts. It is a plan develop a lightweight Android app using Flutter React that connects our API. This allows villagers or technicians to receive or push notification through SMS or email, Android, and manual verification photos from the water source. Next,
Myself, I'm making learning outcomes. In learning outcomes, there are 3 major learning areas: basic machine learning, dashboard front-end development, data preprocessing. Basic machine learning is understanding pictures, pH, humidity, and temperature, variety model outputting, evaluate the correct outcome. Dashboard front-end development is design UI layers for sensor reading, creating clean and data that is useful for the understanding. Planning chart for user using graph and user tools. Creating user alert indication means safe or unsafe. Data preparation, cleaning and formatting sample data using sample data, handling missing or incorrect values, and preparing data for machine learning. Based on water quality early warning systems, we have successfully completed the major software components required for core functionality. A backend API was implemented to process inputs, run predictions, and deliver result effectively. The processing pipelines, models, integrate and alert generator logic are functional correctly. The dashboard UI will be added and integrated in the next phase, but the software backend prepared for the real-time quality prediction and alerting is already operational with 80% of our software completed. And these are the reference.